Here we go. I think it's because it was the 2-hour sessions or hour and a half sessions that I underestimated the difficulties. Okay, anyhow, now this Zoom session is being brought to you by the fractal gold horizon. Now let's proceed. Right. Polar coordinates. Polar coordinates, did I go over this lot? No, this is the other class. Polar coordinates are a different way of dividing up, of putting coordinates on the plane. Rectangular coordinates, you have vertical lines indicating constant values of x, which is how far the horizontal distance. The horizontal lines correspond to y, the vertical distance. A point x by y is x units horizontal from the origin and y units vertical from the origin. Okay. I call this taxi cab space because it looks like a street grid and looks like how a taxi driver might be aware, might consider the space of how the city is divided up. Now the other one, polar coordinates, I call air traffic controller space because it looks like an air traffic radar grid. Here, the circles denote constant values of r, the distance out from the center. And these lines, radial lines, correspond to different values of theta, which is the angle you make from the positive horizontal axis. So r by theta is out a distance r at an angle theta from horizontal to the right. So the angle from positive x-axis. So all right, now here's a point given in rectangular coordinates x by y and polar coordinates r by theta. Now this is a right angle triangle with right angle trig. X over r is cosine theta, so x is r cosine theta. Y over r is sine theta, so y equals r sine theta. And so x equals r cos theta, y equals r sine theta. This goes from polar coordinates and derives rectangular coordinates. Going the other way around, well, r, it's the third side of a right triangle, so use Pythagoras. R equals root of x squared plus y squared. Now theta, we use arctangent, but it's a tricky thing because arctangent only gives you values from minus pi halves to pi halves, and that fits the right half of the plane. But the left half of the plane, you get arctangent doesn't cover, so you have to add pi radians. So if x is positive, then theta is arctangent y over x, because tan theta is y over x. But if it's over here on the third or second or third quadrants, then you have to add pi plus arctangent y over x to add a 180-degree turn. So this goes from rectangular coordinates to polar coordinates, rectangular to polar. I think in some of your hand calculators, if you have one, then there may be an app that says P to R and R to P, which does exactly this. You may want to investigate that. So for example, polar coordinates, r equals 3 and theta equals pi halves. What are the rectangular coordinates? Well, x by y is r cos theta by r sine theta. Putting a 3 in for r. Pi halves here. Cosine, well, pi halves is a 90-degree return, which ends you at 0 by 1. So cosine of pi halves is 0 and sine of pi halves is 1. 3 times 0 is 0. 3 times 1 is 3. So the rectangular coordinates of this in polar are 0 by 3 in rectangular. If it's polar is 6 by 150, what's the rectangular? Excuse me, coordinates. Apologies. All right, it'll be 6 cos 150 by 6 sine 150. And cosine of 150 is minus root 3 over 2 times the 6 is minus 3 root 3. Sine 150 is a half times 6 is a 3. So minus 3 root 3 by 3. Now here we're going the other way around, rectangular coordinates. If the rectangular coordinates are 1 by negative 1, so it's over 1 and down 1 in the fourth quadrant. What are the polar coordinates? All right, well, the polar coordinates are root x squared plus y squared. 1 squared plus negative 1 squared makes 2, and its square root is root 2. Arctangent of y over negative 1 over negative 1 is arctan negative 1, which is minus pi over 4 radians, negative 45 degrees, 45 degrees in the clockwise direction. So out root 2 at an angle of negative 45 degrees. Here, rectangular root 3 by 1, what polar coordinates? Okay, r is root of root 3 squared plus 1 squared. That's 3 plus 1 is 4, root is 2. Arctan 1 over root 3 You can check that out. This is the 30, 60, 90 triangle, which gives you 30 degrees or pi over 6 radians. So 2 by pi over 6. Well, and that's it for this. I would be going onwards to the next. Well, let me at least, well, okay, the next one is section 2, which is an extra credit, and I didn't make up notes for yet. Section 3 goes over the complex plane and De Moivre's theorem. Here we describe, basically we describe, I think we've just seen complex numbers before, right? Well, if not, we'll go over that slowly, take our time. And it too has rectangular and polar forms and involves a special function cos theta plus I sine theta called cis theta, which lives in a unit circle in the complex plane. And it turns out that cis, if you multiply two cis's, you get cis of the angle. And that comes from the angle addition formulas. So there are some rules about how to multiply, divide, and take powers of complex numbers and roots of them, and Sarah will do examples of that, which we'll do in due course. Okay, so okay, I'll call that done for now.